Hi everybody, welcome back to Happy Little Diodes. We're back in with a repair job today. This is a ZX Spectrum 48K. It's very poorly. Let's see if we can mend it. Our serial number is 001632529, which puts it around about the issue 3 era. Let's get in there and see what we actually have. And I see we have an issue 2. The heatsink is an issue 2 heatsink in the bottom right of the board. TR6 is soldered over the CPU, and I can see some variable pots next to the left hand keyboard ribbon. The keyboard ribbon connectors have been beefed up with some plastic glued on there, which leads me to believe that at some point this has had some service work done. Let's have a closer look around this issue 2 board. The ULA is a 5C112E2, week 44 from 1982. This is the correct ULA for this board. If you watched my earlier video on the dead cockroach mod, which was introduced to fix an issue with the design of the ULA, this edition of the ULA fixes that problem, hence no dead cockroach mod, although the fix wasn't quite perfect and in the end they had to introduce TR6, which is what's known as the spider mod. You can see the transistor over the Z80 CPU on the right there. The underside of this board isn't giving any hints of any major rework, just some flux around here and there but nothing too major. Probably a good sign that nobody's tried to repair this and failed. Okay, we need to do a few initial tests and it's going to be a bit easier for us if this heatsink is removed. So there is a nut and a bolt. We need to take that out and carefully slide the heatsink away, keep all those bits together so I don't lose them. The first test I'm going to do today is to measure the resistance from the 3 power supply pins to our lower RAM chips to ground, starting with pin 9 BCC. We've got something which isn't close to 0, so that's a good result. VDD on pin 8, again something that isn't close to 0, so I'm happy with that. And what about pin 1? Good, also not close to 0. That means I can confidently put some power into the machine using the current limiting power supply. But before we get into that, there's another test that I've been doing a bit more recently on these machines. Here's the schematic showing the 8 lower RAM chips. What you can see is that basically all the pins are shared except for the data in and data out pins. However, the data pins all basically go to the same places. Alright, the length of the traces might be different, but generally they're all going to the same places and doing the same thing. What that means to me is that the resistance is going to be the same-ish from each of the 8 pins to ground. So I'm going to measure that and we're looking at about 7 kilo ohms for each one. Any of those coming out as too low or too high would indicate a problem with the board and give us a clue as to where to start looking. Well, in this case there doesn't seem to be any discrepancy, so I'm going to go ahead and put some power in. I'm going to be very quick about this because I've got no heatsink on the voltage regulator. I'm just looking at the current draw, it's about 600 milliamps, that's about right. So next step, we're going to check our voltages. Here's a little table from the service manual. I recommend getting hold of a copy of that if you're going to be trying this kind of stuff yourself. And we're going to check for those nominal values and check that we're within the tolerance, starting with minus 5 volts. We got minus 4.3, that's perfect. On 12 volts we had 11.6 and our 5 volts is about 4.8. All within tolerance, lovely. Now I'm rushing this a little bit because again I haven't put the heatsink back on. I recommend you take your time and put your heatsink back on. So things are looking good for this board. Let's plug it in. Okay, it's not looking too good. We've got purple border and some red vertical lines. The red vertical lines normally indicate a problem with memory, probably lower memory, but the purple border is a bad sign. Purple border indicates a problem possibly with ULA, CPU, ROM, who knows. Let's put a diagnostic ROM in and see what it tells us about this board. Well, it kind of looks a bit like the startup, but it's a bit garbled. I can't explain. Okay, I have no idea what's going on here. That is really unique. I think this board is possessed. That's a really strange failure mode. If you've ever come across anything like this, drop a comment down below please and let me know. It's the first time I've seen it. So I need some more clues, some more information. I'm going to scope around some lower RAM pins and see if anything looks out of place. I'm already seeing that something doesn't look right, some signals are being held high or low. Let's focus in on pin 3. I'm going to get to pin 3. That's the right pin to the lower RAM, and it looks like it's being held high. There's obviously some kind of square wave trying to get through there, but something has gone wrong, and we're going to have to think about the chips which are involved in the generation of this signal. Which isn't many, it's just the ULA, which is a bad sign. That's the chip that we don't want to die on these boards because it's very expensive and hard to find. I'm going to try this newer ULA, which I know works, and let's see what we get. Oh, well, we should be happy it's working, but we should also be unhappy that it looks like the ULA which this board was built with isn't working anymore. But at least that seems to be the only issue. One of the only issues that this board's got. We've got 2 bad upper RAM chips. Okay, we'll swap those out. Let's get those swapped out and see if that's the only problem with this board. Now I know that they're dead, I trust the ROM. I'm just going to cut them out because it's quicker and easier, unless you have a desolder gun, which I don't have. This is a dead handy method of removing chips which you know have failed. Just cut the legs right up against the body of the chip, remove the body of the chip, and then remove each of the pins individually with a soldering iron and some tweezers. I normally just use my snips to pull them out rather than tweezers because they're already in my hand and I'm lazy. Now I do implore you to be careful. This seems like a safe method, but it's not really, because what I'm pulling on there is one leg which is connected to 1 or 2 traces or just one joint, and it's very easy to put too much force through if you haven't fully melted all of the solder. So make sure that your soldering iron is hot and clean, and make sure you've melted that solder before you pull the leg out, otherwise you'll lift a trace or damage a pad, which I have done in the past. All that remains is to clean the joints of solder using your solder socket. I find this a bit awkward when there's no leg poking through because there's nothing really to brace against, and I tend to sort of slide around and miss the joint when I press the button on the solder socket, but you get the knack of it. Alright, looking good so far. It's normal practice to put sockets in when you're replacing chips. Just helps things in the future. If you have to rework these chips again, you can just pop them out without having to do any desoldering, which risks further damage to the board. So put your sockets in place. I solder opposite corner legs of the socket first, and then I hold the socket in place with my finger, gently pushing on it while I melt each of those joints I've just made individually, just to make sure the socket is sitting flush to the board and looks good. So socket soldered in place, let's pop in our replacement upper RAM chips, 4532 chips. And let's run our diagnostic routine again, see what we get. Excellent, we're up and running. Just a shame about the ULA. Before I call time on that old ULA, I'm going to just check it in another issue 2 board just to make sure that it's definitely gone. So here's our old issue 2 ULA, and as a reminder, it was possessed by the devil and speaking in tongues. What I'm going to do is plug it into another issue 2, and I'm going to see if we get the same failure mode. So here's my spare issue 2, the ROM is soldered in, so let's just see if we get the purple border. Yes, we do, exactly the same failure mode. So sadly we're going to have to call time on this issue 2 ULA and add it to the box of dead ULAs. I'm going to label it because I have been known to put in a dead ULA while repairing a board, forgetting that it was dead. At this point you might say the board is a financial write-off. That's because it is, but this belongs to somebody and they want it fixing and they're willing to buy a new ULA to put in it, which is fantastic news. Another speccy will live on. This is my green light to continue with the service tasks, starting with a changeover of these capacitors to new ones. All these blue electrolytics are 40 years old now, and it's normal practice to replace them all. Notice this black radial capacitor at the top there, that is another part of the service mods which these boards had. It's an improvement to the power circuit. I'm going to replace that capacitor as well. It is a good idea to take your time and replace 1 or 2 capacitors at a time, powering up the spectrum in between each set of replacements just to make sure that nothing has gone wrong along the way. I'm doing them all here because I've got a pile of these to do and I'm getting pretty good at doing this now without cocking anything up. I am in the habit of doing this work with the board in a vise, obviously not tightened up too much. I would rather do this over using alligator clips. I have had repairs where the owners had it in a board holder with alligator clips and it's cut traces on the board because of the teeth on the clips. So I prefer to work this way. It just makes life easy when clearing the joints, doing what I'm doing right now. My process is to cut one of the legs of a capacitor close to the body of the capacitor, bend it up and remove that from the board, and then use tweezers or my snips to lift the remaining leg out of the board. Then I go around the board with the solder sucker, clearing all the joints, and that allows me to put the new capacitors in place and solder them all in. There's plenty of resources online which tell you which capacitors you need and how many of each capacitor. One thing to be aware of with these issue 2 boards is that C46, the 1 microfarad capacitor, goes in the other way round to what is printed on the board. That is an error which is specific to issue 2 boards. Our final job is to replace this capacitor, which is a 4.7 microfarad radial capacitor added to the power circuit as part of an upgrade. Now this isn't just an extra capacitor, be careful, you need to change R60 from a 100 ohm resistor to a 270 ohm resistor, as well as adding this capacitor. So with that soldered in place, I'm going to neatly bend it this way, in a way that doesn't impede any extra peripherals going onto the edge connector, and allowing the case to be closed. Now here's an interesting thing, we've got minus 4.9 on our minus 5 volt supply. Previously we had close to minus 4.3, so we are much closer to nominal. 12 volts is looking good too, and what about our 5 volts? 4.8, pretty good. Next up on the service task list is to remove the socket, the ULA socket, so that we can fit a heatsink to the ULA, solder it directly to the board and still be able to close the case. Now it's kind of contentious, you may or may not think this is necessary as the ULA is working within its limits in terms of temperature, and the potentially small benefit to the ULA's life is weighed up against the risk of reworking the board in this way, so I'm going to be careful and make sure that I'm not going to damage the board and we get the benefit of the heatsink on the ULA. What do you all think, heatsink or no heatsink? Anyway, with that removed, I'm going to tidy up these joints and we're going to slot in our 40 pin DIL socket. I am also going to do a composite video mod on this. This is obviously down to the owner's preference. I think in this case we're going to do it. You might wonder how I've been getting video out of the machine, because I definitely haven't been tuning into analog every time. Well, I've just been holding the connector against the side of the modulator just to get a picture out for the diagnostic work. Anyway, there's our 100 microfarad capacitor in place, composite video mod done. The only job left on this board is to clean the edge connector. You might prefer to use a rubber or a fiberglass pen. I'm going to go with fiberglass pen. Lovely, we can put the heatsink back in place now and finish our work on the board. What about this keyboard membrane? I have high hopes for it. It seemed to be in good nick and it had been serviced, and unfortunately no, it didn't work, which means we need to get the faceplate off this thing, and being an issue 2, it is glued on. The later issues they're held on by brass tabs, which is much easier to remove, but I'm going to have to go with the heat gun and trying to carefully remove this without bending it. I have heard tales of people putting the cases in the oven to get the glue to soften up and remove. Maybe I'll try that next time because this was a pain. Anyway, I got in there in the end. Let's remove the old crusty keyboard membrane and we can pop in a shiny new one. If you watched a recent toast rack repair video I uploaded, you might have learned that you shouldn't leave these things out in the sun. Just a storage tip, don't leave your keyboard membranes in direct sunlight because it seemed to cause a problem, at least on the keyboard membrane I was working with then. We want our faceplate to go back on nice and neat and flush, so I'm going to remove this old glue sticky tape stuff by scraping away at it. You can also use alcoholic spirit or WD-40 to help remove all this nasty glue stuff. Perseverance pays off in the end, and this is looking very clean. Double-sided sticky tape is the best way to do this, I've found. We're going to put 4 strips of it on the top and the bottom and on the sides. And top tip, thank me later, you need to test the keyboard membrane before you glue the faceplate back on, because if you do have a bad one, you're going to need to remove it again. This one is working perfectly, so let's get the paper off this double-sided sticky tape and stick it back down. Very nice. Now we did all that work desocketing the ULA, let's put our heatsink on. I'm just sticking it down with some double-sided thermally conductive tape. And finally, before we put the case back together, we're going to tune our composite video signal. I'm scoping the input to the modulator and I'm tweaking these two variable resistors for minimum noise. That being done, I'm going to replace these 2 feet which are missing. I do have some spares, but I also have a big sheet of rubber which is about the right thickness that I sometimes just cut into little rectangles that fit perfectly. One last important test is to make sure that it will work with this DivMMC interface. That is testing that the Z80 is working correctly, and it is, which is fantastic. Alright, lovely. That just about concludes this repair job. Thanks for watching, and please be sure to subscribe if you haven't already. Please like, please share, and please join in the comments below.